So now our goal is to do the same thing we did for the sine function, but with the cosine and tangent functions. And we're going to use the exact same approach. I'm going to start with the cosine function with its graph. Then I'm going to reflect that across the line y equals x. And I'm going to have the same problem occur. This is not a function. If you pick an x value, it has lots of y values associated with it, and that's not okay. So I'm going to fix this just like I did with the sine function. I'm going to restrict the range. I'm going to start here at the far side at 1, and I'm going to go along the path to -1, and that's where I'm going to stop. I now have a complete set of y values, right? Every possible output value of the cosine function is covered here. So I'm going to eliminate everything else, and that will be my inverse cosine or arc cosine function. So just like we had with the inverse sine, where the only possible output values were between -pi/2 and pi/2, we have a similar situation here with the inverse cosine. The range of the inverse cosine function goes from 0 up to pi. All right, so those are the only, that should include pi. From 0 up to pi. Those are the only possible output values. All right, so let's look at a couple of examples here. All right, what is the inverse cosine of the square root of 2/2? Remember what this is asking is the same thing that we had with the sine. This is saying what angle has a cosine of the square root of 2/2. And in our range from 0 to pi, there's only one, right? This has to be pi/4. All right, so how about the inverse cosine of -1? Well, again, I'm thinking in my head, I need an angle whose cosine is -1. The first number that comes into my head is pi, and that is in our range, right? So that one, is fine. All right, so how about the inverse cosine of -√3/2? Well, you could go negative. Well, you can't go negative, right? The cosine, I think, is a little easier than the sine, right? Because your first thought is a first quadrant angle, but those are all positive. So kind of your next natural thought is, well, how about the second quadrant? And the second quadrant is part of the inverse cosine's domain, right? So the inverse, so I'm thinking, what angle has a cosine of -√3/2? Right, I'm thinking that's going to be pi/6, right? And that does it, right? What am I saying? Pi/6. Sorry, 5pi/6. Pi/6 would be positive square root of 3/2. Right, so 5pi/6 will be my answer. And again, right, we're mirroring a lot of what we did before with the sine. If you have the inverse cosine of a kind of a non-standard number, you can always go to your calculator, right? My calculator tells me that this is 1.77. That is between 0 and pi, right? Pi is 3.14 something, so that is an okay answer. And again, your calculator knows these ranges, so your calculator is always going to give you an answer that's in that acceptable interval. Okay, so again, let's talk about this same kind of question we did with the sine. Remember that the driving principle here is that the inverse cosine and the cosine, they cancel each other out. So what I want to say here for this first one is that this is pi/8, and that's a good answer. Pi/8 is between 0 and 2 pi. That works. All right, so that's a good result. Now, the next one here, we're going to have to be a little creative, right? If I just let these cancel each other out, I get negative pi over 7, but that's not okay because that isn't in our range. And that's not between 0 and 2 pi. All right, so how can I fix this? Well, just like with the sine, think about reference angles. Right? I got this reference angle down here. Right? This is negative pi over 7, but you can see first I need to get this to where it's in the first or third quadrant. Well, I need or first or second quadrant. So I need an angle that has this same x coordinate. Well, if I bring this up here, that's going to work, right? And that angle is pi over 7. So there's my answer, right? It's actually positive pi over 7. All right, so try this next one. Try 9 pi over 7. See what you come up with. All right, so I'm going to take the same approach. Right, 9 pi over 7 is a little greater than pi. So it's going to be down here. And this reference angle is going to be 2 pi over 7. So I need an angle that gives me this same x coordinate, but is in the second quadrant. So if I draw that here, bring this up, this is going to be 2 pi over 7. All right, but that's not the actual angle, right? If I look, terminal side or the initial side and terminal side, I need this angle here. Well, that angle is 5 pi over 7. That's going to be my final result. So how do we do the tangent function? Exact same method. Right, I'm going to take this tangent graph, I'm going to reflect it across the line y equals x. I'm going to look at this, and I'm going to say this doesn't work. This isn't a function. I have to restrict my range. So I'm going to take one complete set of values, right? And that'll be my restriction, right? So I'm going to get rid of all of the other branches, and this is where we're left, right? So the range of the inverse tangent is going to be numbers from negative pi over 2 up to pi over 2, and be careful with these, right? I'm actually not going to include negative pi over 2 and pi over 2, right? Because if you look at the graph, those are asymptotes. The graph never actually gets to those numbers. There is no x value that gives me negative pi over 2. There is no angle whose tangent is pi over 2 or negative pi over 2. So those two we're not going to include here. Okay, so this sums up everything we've talked about, right? It's got the domains of all three functions and the ranges of all three functions, right? And you notice, right, and we didn't really talk about the domain very much, but the domain of the inverse is the range of the original function, because the sine function has y values between -1 and 1. Those are the only values we can use as input values to the inverse sine and inverse cosine. If you don't believe me, ask your calculator what the inverse sine of 2 is. It's going to get a little upset. Right, and I also have the ranges here, right? This is the kind of thing it's useful to maybe print out or write down on an index card, at least until you get used to it, right? So you make sure you're always giving an answer in that acceptable range. Okay, so the problems, if I ask you for the inverse tangent of a number, those go exactly the same as the sine and cosine ones we've already seen. Right, so what I want to do here before we move on, I want to talk a little bit about finding inverse functions. And the way we do this is exactly the same way you're used to doing it from your, I don't know, probably college algebra class, right? Remember this f of x, this is the same as y. And how do we find an inverse function? You switch the x's and y's. So I'm going to make this x equals 3 cosine y minus 1 plus 2. And then I'll solve this for y, just like you would with any algebraic equation. Subtract 2 from both sides. X minus 2 equals 3 cosine y minus 1. Divide both sides by 3. Cosine y minus 1 equals x minus 2 over 3. And now here's where we're going to use our new function. I'm going to take the inverse cosine of both sides. Inverse cosine y minus 1 equals inverse cosine x minus 2 over 3. These can't kind of cancel on the left. And we're left with y minus 1 equals inverse cosine x minus 2 over 3. And add 1 to both sides. Y equals 1 plus the inverse cosine x minus 2 over 3. And now I was asked to find the inverse function, right? So I want to make it really clear that this is the inverse. So I'm going to add f inverse of x equals that expression, right? And that's all there is to it. It's the same thing you did, back in your previous algebra classes. All right, so let me give you one real quick, right? Take this one out, see if you can't find the inverse of f of x here. All right, so let's see, I'm going to do my switch. I'm going to make this x equals negative 2 tangent 2y minus 3 minus 1, and solve this for y. Let's move the 1 over. X plus 1 equals negative 2 tangent 2y minus 3. Divide by negative 2, tangent 2y minus 3 equals x plus 1 divided by negative 2. And now here's the inverse step. Take the inverse tangent of both sides. That gets rid of the tangent on the left. 2y minus 3 equals inverse tangent x plus 1 over negative 2. Add 3 to both sides. 2y equals 3 plus the inverse tangent of that expression. And one more step, divide both sides by 2. Y equals 3 plus inverse tangent x plus 1 over negative 2, all divided by 2. And again, right, let's do what we were asked to do. We were asked to find the inverse, so I'll write it that way. And there you go. There's my answer. All right, so what comes next? What comes next is solving equations, right? That's really kind of what we needed these for. That's what we're going to do. And I kind of referenced the square root function, right? As kind of a parallel when we're talking about the sine function and why we had to restrict the domain. We're going to get the same kind of situation when we start solving equations. Just like when you take the square root of both sides of an equation, you always do that plus or minus because we want all the answers. We're going to have to do something similar when we start solving trigonometric equations.